A new method in a derived class can redefine a method in a base class in order to give it a new implementation. To demonstrate this, we'll redefine rectangle's getArea method by redeclaring it in triangle with the same signature. The signature includes the name, parameter list, and return type of the method. If we now create a triangle and invoke the getArea method, triangle's version will get called. However, if we upcast the triangle to a rectangle, we will instead call rectangle's version. This is because the redefined method has only hidden the inherited method. That is, triangle's implementation is redefined downwards in the class hierarchy to any child classes of triangle, but not upwards to the base class. In order to redefine a method upwards in the class hierarchy, what is called overriding, the method needs to be declared with a virtual modifier in the base class. This modifier simply allows the method to be overridden in derived classes. Calling the getArea method from rectangle's interface will now also invoke triangle's implementation. It is still possible to access a redefined method from a derived class by typing the class name followed by the scope resolution operator. This is called base class scoping and can be used to allow access to redefined methods that are any number of levels deep in the class hierarchy. Another place where this is important is in the constructors of derived classes. Base class constructors in C++ are not implicitly called by derived constructors as they are in C# and Java. Instead, they need to be explicitly invoked from the beginning of the derived constructor's initialization list in order to construct the base class. Note that we here don't have to qualify the base constructor with a class name, since this is implicit.